Most continuous production processes operate for less than 30% of the time in ideal state, which represents substantial losses in terms of production output, costs, asset performance, quality, and impact on the environment. The time in state program implements a solution that increases the percentage time in ideal state and thereby delivers higher operational efficiency and effectiveness. Results include more than 18% increase in production output and increases in energy efficiency of over 7%. These improvements translate into multi-million-dollar gains. These gains are delivered without changing the production process or equipment configuration. In any continuous process, maximum productivity is reached when equipment function in ideal state or the optimum operating envelope as much as possible. The problem is that processing plants observe significant variance in performance, irrespective of sophisticated process control systems. In fact, most continuous processes run in ideal state for less than 30% of the time. Needless to say, this has a massive impact on profitability. Over the past few years, various performance measurements like OEE have been applied in industry. Unfortunately, these solutions have their limitations and, although perfect for discrete processes, they can mask inefficiency in continuous processing plants. The time in state metric was developed with the objective of empowering operational personnel in continuous process environments to proactively affect performance and profitability. Time in state is a MESA International endorsed metric.
The traditional metrics basically had more a reporting, it happened yesterday type of outlook, and we replaced that with IME replaced that with the view of what's happening now.
It actually takes into account the changing nature of the continuous processes and the effective reaction to adverse factors influencing them, making it a far more useful metric for proactive management of the production process. The time in state system is implemented in various phases, starting with a current state definition and the compilation of a performance driver matrix, a critical element to facilitate emotional and intellectual engagement. Time in state analytics is then used to extract and visually represent variable interrelationships in performance maps. These maps aim to define specific operating conditions that associate with high performance.
The implementation of the IME time and state metric was a fairly easy process.
It was well facilitated.
They had constructive communication with these guys. So in explaining to them what the process is doing and what the model will help them to do,
there was frequent interaction and face-to-face contact.
Continuous measurements are depicted on performance maps as a matrix of values describing process behavior and conditions. This way, patterns become apparent and enable the identification of internal benchmarks or baselines.
They've taken a vast amount of data, looked at the data, analyzed, saw the trends, and identified the major KPIs that contribute most to the optimal functioning of the plant.
A well-documented and well-defined reporting tool.
Time and state was essential to see when we were getting the best performance out of specific units of operations.
It takes out personal preferences, past experiences, and looks at the data and information at hand to inform the optimization process.
After deploying and integrating time in state models with a control system, the system continuously tracks when and how close the functional unit is operating to baseline, while depicting the key influencing factors that are causing the unit to deviate from ideal state. A user-friendly graphical interface further empowers operational personnel to address issues in real time. The performance index dial on the top left-hand side indicates how close the system is operating to the ideal state, represented by the green range. To the right of the dial, the key process influencing factors are displayed as bar graphs. The dial will move outside the green range as soon as any one of these key factors exceeds defined constraints, and the particular key factor bar will turn red. An information box in the lower middle part of the interface displays context-sensitive information, which will enable and guide operational staff to take the best course of corrective action.
It's a much simpler and easier way for the operator in the control room to know this is the first thing I need to actually go and do. And that has got a real-time effect on the production of the plant.
After implementation of the solution, mapping is repeated for the now more stable process to confirm assumptions and mental models. Detailed reporting provides practical and useful functionality to management.
A big benefit was that IME came to site. They spent time with the foreman, they spent time with the control room operators.
The weekly meetings, especially in the initial stages, were key to actually make sure the bigger team were all aligned.
We managed to get real facts where people got debates on an open forum without funny opinions and misguided opinions coming into play. So it really did serve to focus a lot of our discussions and our optimization sessions.
The implementation of the time in state metric brings about considerable financial improvements within continuous process industry companies. It enables excellent control over operational risk, simplifies usually complicated decisions, and minimizes unpredictability by addressing variances in efficiency in real time.
Improving recovery has a major financial benefit to us.
We actually saw improved recoveries, and there was a definite improvement in the quality of the product that we produce. So that was a huge financial benefit.
Time and state is also an invaluable tool in terms of motivating capital to be spent in the organization.
We've seen a significant improvement in plant performance.
There's a significant cost benefit in changing a piece of kit in a planned fashion rather than in a breakdown fashion.
Reducing production losses and also created a sense of stability and predictability on the plant as well.
Processes and procedures are streamlined and optimized like never before, enabling the continuous process plant to reach and maintain highest levels of efficiency.
We use IME anywhere in the capital-intensive industries, in mining and minerals, in pulp and paper, in cement.
All those industries will definitely benefit from using the methodology of time in state and the time in state metric as a measurement of their improvement and of their effectiveness.